First of all, what we will be going to talk about in this, we will be going to talk about machine learning pipeline. So what an end-to-end pipeline in machine learning looks like. So it all starts with a problem definition. Let us say you are working with some company. So they have given you some problem definition, like in the form of they have given you some problem definition, and in the problem definition, you have to write down your aim and objective. So like what we want to accomplish in that project. So the first step in machine learning pipeline is problem definition. Yeah. So problem will be given from your stakeholder. What you have to do? You just have to write down your aims and objective, like what we are going to do in this project. The second thing that you need to know about is your domain knowledge, also called as business understanding. Suppose that you are a banking data scientist or data analyst. So you need to know some basic background knowledge of banking industry, like how banking industry works, like what are the key terminology in banking industry, attrition rate and everything. Similarly, if you are working in a telecom sector, you need to have a domain knowledge of a telecom sector. Similarly, for flight industry, same thing. And for geospatial industry, same things. You need to have a domain knowledge about it. Yeah. So it totally depends upon which domain you are working. So it can be a financial domain, like your stock market, let us say, your mutual fund company or some hedge fund company you are working. Next thing, it can be banking industry also. Then it can be aviation sector also. Aviation sector, yeah. Next, we can have any agriculture background also, like you can become agriculture data scientist also. Then we have something called as geospatial. Geospatial basically means satellite types of data. So you are working with some companies like aerospace companies. So you need to have a geospatial domain knowledge of that area. Then at last we can have a medical domain knowledge. So you are working as some medical company, you are working as a data scientist. So you need to have a knowledge on medical domain. So all the key terms associated with it, you must need to know about it. Is it clear?
Yes.
Yeah. Third of all, what we will be going to do, we will be going to collect your data. So let us say you are working on a project. So either the stakeholder will provide you the data or you have to collect the data on your own. So we can gather the data set from publicly available sources like World Bank, Kaggle, open source data, Statistica. So all these various websites are there. You can just gather your data. Some other websites also called as Google Dataset Search. So you can just go to Google Dataset Search and just type your keywords here. So by just typing your keyword, you can get a list of links which are available. For example, let us say we are chemotherapy, let us say chemotherapy dataset. So you can get list of links which are available in the market. Clear? Some other dataset that you can use is something called as IEEE data port. So in this data port, you can also get some dataset here. You have to just create an account and you can just download all the types of data that is available to us. Clear? So data can be of paid also, can be of free also. Next thing is API. So we have various APIs available for us in order to extract the data. For example, a simple API called as Yahoo Finance for extracting the stock market data. Then we have Zillow. So Zillow is an API for collecting the real estate data. Similarly, we have various types of APIs available to us, which we can use to gather the information. Next thing is, you can collect the data set from social media platform just by scraping it out. For example, you go to Twitter or you go to a Reddit platform and you extract the data from it. Okay? And then we have surveys or feedback. So you are doing manual surveys by distributing a form online and some users are filling it out. So you can do manual surveys also. This is a time-taking process and consuming process when you are doing surveys or manual feedback. it is normally preferred. Let us say you are working on some idea and you want to validate that idea. So you need to go around and ask with people that what is the use case of this, how much you rate out of this. So you just have to collect the feedback on your own. So a company like DoorDash has done surveys around in 10 to 12 plus cities in order to just find out whether their startup idea is valid or not. Yeah. So DoorDash is an American company which is used for delivering the services. And at last, we have web scraping. Web scraping is like scraping the information from the internet. So sometimes there can be a constraint also, like you cannot scrape everything by your own, or you will face severe lawsuits, like OpenAI is facing right now, because he has scraped all of the websites over the internet. So that's why he's facing some issue. Clear? So is there any doubts in the data collection part?
Yeah, I got it. Social media, different media API scraping. Yeah.
Next thing, now what happened? You gather the data set from various sources. So there can be many sources present to us. Like it can be an API, it can be in CSV file, it can be in JSON file. So there can be many file types. So you are extracting the data set from various sources. After that, you are loading it and then you are doing the transformation. So this is called as ELT. So data integration you have to done. Like there is various file format. You have to combine all the file format into a single file format and store it in a data lakes. So have you aware about the concepts of data lake and data warehouse?
No, data warehouse concepts. I know things. The ETL tools in PySpark and all the things using for to store the data in the database for the scraping purpose. They use different tools. The data engineering team, they're doing these things. But yeah, I am not did any work on this.
Okay, no problem in that. So basically what happened in a data lake is basically you do ELT. ELT means first of all, you are gathering the data set, extracting the data set from various sources. After that, you are loading into a single thing, loading into a data lake. So all the data files will be combined, like data integration steps will be performed, and it is stored in the data lake. Once the data is stored in data lake, after that you can do data pre-processing steps like cleaning the data. Clear? So it can be many file format like CSV can be there, JSONs can be there, there can be ML format, then can be Parquet format, which is a big data type extension. So there can be man format and you can just transform it there. So
okay.
So this is happening data lakes.
Okay, got it.
Another important point about data lake is that it can deal with unstructured data also, like structured data, unstructured data, and semi-structured data. It can deal with all the three types of data. So what is structured data? Structured data means data is in the format of rows and column. Unstructured means data is in the format of text, images, or audio. So this is unstructured data. And then there is a semi-structured data, which is an integration of structured as well as unstructured. So data lake is capable of all the handling with all the types of data. Clear?
Yeah, got it. Yes.
Next, we have something called as ETL. So whenever you are loading into data warehouse, so we do ETL. So here we are doing the same thing, extracting the data set from various sources. Then we are cleaning it out and after that saving it in a warehouse. So data warehouse only deals with the structured data, or you can say clean data only. This can deal with all the types of data, but this can deal with only structured data. So this is called as ETL. Clear?
Yeah, I know it. Yes.
So data integration steps is very much important because we have data coming from various sources and we have to integrate all the data set into a single sources. That's why data integration is applied. Next step, we do something called as feature engineering. So there can be different steps for performing the feature engineering. For example, if you have a tabular data, you have different steps. If you have images data, you have different steps. And if you have audio data, you can have different steps for data cleaning, etc. Then we have something called as feature engineering. Feature engineering basically means you are deriving new features from the existing data. Suppose that I have a age column given here. Age is written like this, 0, 10, 20, 30, 40. So you can create a new feature called as age category, like teenager is there, adult is there, or senior citizen is there. So you can create a new column based on the existing column. So this is called as feature engineering. Yeah. In SQL, we do the same thing. We call it as
data. I know what a feature engineering is.
Yeah. So in SQL, we call the same thing as data binning, like 0 to 13 child, 13 to 19 teenager, after that adult, after that it will become senior citizen. So let me just talk about what are the steps involved in tabular data. So first of all, what you will do, you will check your data manually. Like you are opening your file and you are checking the data manually it out. Once this thing is done, next step, what you will be doing, you will be loading your data. If it is a, let us say, if we have a simple data like 100 MB's data or 200 MB data, you can use Pandas library. If we have big data like 1 GB data, 10 GB data, in that case, we can go with PySpark. So here, if we have large types of data, we can use the concept of what we can say partitioning. So you can apply the concept of partitioning to load the data at a very fast speed. Okay. Next thing, what you have to do, you have to check for the spelling errors in column name. Like if there is any spelling error in column name, so you have to fix it out, or any spelling error inside the columns. Next step, what you are going to do is look for data entry error. Data entry error, such as negative values. Suppose that we have a price column given here and someone introduced negatives in front of it. So what we will do, in order to fix it out, we will be applying the absolute function to fix it out. Okay? Once this thing is done, the next step, what we will be going to do is you will be checking for missing values. Then we have duplicate values and outlier. It is optional depending upon the domain you are using, because sometimes you have to deal with the outlier and sometimes you just leave as it is. So it totally depends upon the domain you are working that you have to remove the outlier or not. For example, let us say we have a case of financial transaction data, like fraud transaction data. So in that case, we cannot drop outlier. So we have to leave as it is. So it totally depends upon the domain that you are working, that you have to, whether you have to keep the outlier or you have to delete the outlier. Next, we have something called as check for the data imbalance. So what is data imbalance? Let us try to understand. Suppose that we have 100 students. 70 of them are boys, 30 of them are girls. So you can see that both the symbols, boys and girls, are imbalanced in ratio. So what we can do, we have to fix this data imbalance, like making them equal. Clear? Any doubts?
Yeah.
Okay. Next thing, you have to check for the data skewness. So data skewness you have to check. So it is applied for the numerical column. For example, you can say we have a numerical column there and all the values are on the right hand side. So it is called as left skewed distribution. Similarly, all the values are on the left hand side. It is called as right skewed distribution. So we have to fix these kinds of things. By applying, you can apply logarithm also, or you can just scale your data. So you can fix your data skewness. Once this thing is done, next you can do it for multicollinearity. Multicollinearity, yeah. So what is multicollinearity? Let us try to understand. Suppose that you know about correlation, right?
Yes, I know about correlation.
Yeah. So whenever we have a very high correlation between the features, it indicates the problem of multicollinearity. So whenever there is, let us say, two features are there and they are very highly correlated, what we do, we just drop one of the features to solve the problem of multicollinearity. Next is, you can check for the cardinality between two categorical values. Cardinality between two categorical variables. Like cardinality basically means association between two categorical variables. So you have to fix them out also. Clear? So these are the data cleaning steps which are involved. You can see which are involved in tabular types of data. Cardinality. Yeah. So any doubts in this?
No, it's clear.
Yeah. Now, once your data is cleaned, now you can perform the feature engineering thing in this to create some more new feature. Why it is needed? Whenever we have less features in the data, we can derive some existing features. Once the data part will be done, what we will be going to do? We will be going to do something called as DVC. Like you will version your data. For example, I have cleaned the data. Now I'll name it as version 1. Okay? Version 1. Now, if I make some changes in the data, I need to make it as version 2. So DVC, what it will do? It will track your data changes. Like whenever there is a change in data, it will just report it out to you. Yeah. It is very important because sometimes you lost track. Like in your training time, you are using version 1 data, and in the testing time, you are using it with version 2. So there will be misconnect will be there. So that's why versioning will be very much important. Okay. So it is used for tracking the changes in the data. So you can, whether it is a 10 GB file or even 100 GB file, you can do it with the DVC thing. Okay. Here you can write tracking the changes in the data. Any doubts?
No, it's okay.
I think we have. Okay. There is one more thing you can introduce it out. There is one simple thing. Basically, remove the features which are not relevant. Like sometimes what happen, there can be many features which are not that much needed. So you just have to delete them out. Now this thing is done. So this thing is clear, data versioning.
Yeah, it's clear. Yeah.
Okay. Next thing, there is something called as feature store. Now, once your data set is cleaned, your features will be, you find out the most important feature. What you will do, you will store all the features in the feature store. So we have a tool called as Feast. So we can use Feast for the feature store part. So all the features will be stored inside this. You can say go down. Click. Now, if you want to use it, you can just call it and use it later for the later purpose. Yeah. So there is a tools like Feast and Tectron. We can use it out. Normally in the industry, Feast is preferred. So Feast can be used for feature store. Clear? So the benefits of using feature store is like whenever you are doing a real time, real time prediction. So it is fetching the up to date feature, not the old version featured. That's why feature store is very much needed nowadays. Okay?
Yes.
Next, one the basic things is done. You can plot your graphs and perform some statistical analysis and represent using the dashboard. So you can use Python programming language also, R programming language also, or you can use some tools like Tableau, Power BI, Qlik. So all these tools can be used to represent your analysis, like what are the insights you have obtained. Okay?
Yes, got it.
Next thing, what we will be doing, we will be splitting our data sets into 3 parts: training, validation, and testing. So let us say we have 100 rows, 70 of them goes in training, 20 of them goes in validation, and 10% goes in the testing part. Now, once this thing is done, next, what we will be going to do, you will be choosing your appropriate machine learning algorithm or even deep learning algorithm, or you can make hybrid of both machine learning as well as deep learning. So are you aware about the hybrid architectures?
Hybrid architecture?
Hybrid architecture. Like not a single algorithm will be there. There can be combination of machine learning plus deep learning plus machine learning, and there can be multiple machine learning algorithm or multiple deep learning algorithm will be there.
Yeah, I am aware about the algorithms, like in the supervised what algorithms come, unsupervised what algorithms will be there, in the clustering what algorithms will be there, and same algorithms we can use execute all the things in the deep learning also. Like this same algorithms in the deep some of the different, like some will be like depend on the use cases, which are use cases it's belongs to either classification or the regression. Depend on that we have to use a particular algorithm for that.
Yeah. So basically, we are talking about hybrid architectures. So normally in industry, what happens, whenever you try to develop out new algorithms or new machine learning algorithm, you have to go with the hybrid architectural methodology, you can say. So you will be taking various machine learning algorithm or various deep learning algorithm and combining it into a single algorithm. Okay? So this is called as hybrid methodology, you can say. Hybrid methodology. Simple algorithm you can also apply, and sometimes you have to apply hybrid methodology. So mostly this one is also preferred. Now, once you have selected your algorithm for your model, what you will be going to do, you will be training the model on your training data. Okay? So you are training the model on the training data. It will take some time depending upon what is your power of your GPU or CPU. So it will totally depends upon that. Next, once this thing is done, what we will be going to do, you will be making the prediction on the validation and testing data. Like make the prediction on the validation and test it. And then you evaluate the performance of the model. So let us say if it is a classification, you can choose accuracy, precision, recall, and F1 score. If it is a regression model, you can go with root mean squared error. If it is clustering, you can go with Silhouette score and Baldwin index. And if you an association rule, you can go with some different algorithm. Clear?
Okay.
So various types of algorithm will be there. Various model performance will be there. Once this thing is done, what we will be going to do, we will be going to conduct something called as hyperparameter tuning. So what is hyperparameter tuning? We have various values given it out, and I want to find out on which particular value I am giving the best result. So this is called as hyperparameter tuning. So you can implement it with the help of a library called as Optuna. So this is the most advanced library. Normally nowadays, this one is most preferred. And some basic libraries called as Grid Search or Randomized Search CV. So this thing will be used for hyperparameter tuning. Any doubts in this?
Yeah.
Next thing, once you have done your hyperparameter tuning, you will be finding your best sets of hyperparameter. Now you will again fit your model and then make the prediction on the validation and testing data. Okay? Now let us say you are doing experiment with multiple machine learning models, multiple deep learning model. Now what you have to do, you have to find out the best algorithm, and then you have to do the carry forward thing with other steps. So
okay.
Evaluation of the model performance will be there. Once this thing is done, you have found your best model. Now, what happened when we do the experiment? We tried out many different values or many different algorithms, right? Let us say you want to track every single values or every single algorithm that you are applying. So values, parameter, graphs, plot. If you want to track all those things, we have used something called as ML flow. So ML flow is used for model versioning, model tracking, parameters, plots, model, performance, everything you can track it using the ML flow API. Clear?
Yes.
This is very much important because sometimes what happens as a data scientist, what happened, if you want to go back with your previous experiment, you forget like what is the value that I've got in my previous experiment. So I have to totally track it down. Clear?
Yes.
Once this thing is done, now what we will be going to do, you have to do something called as model interpretability and explainability. Let us understand this thing. Suppose that I have built an image classification algorithm. My model says that this image is cat. Now, how can we make sure that the output it is giving, is it accurate or not? Like, is it trustworthy or not? So here, trustworthy things comes into the picture. Like, how reliable your algorithms are. Are you going to trust with it? Because if a single change will be in the input image, there can be different result. So you need to make sure that how reliable your algorithms are. Because if you are working in a medical sector, you are dealing with the life of patient. If there is an incorrect diagnosis, the patient is going to be get tired. So there is a new field of machine learning get involved in this called as explainable AI engineer or explainable ML engineer. So they make sure that the algorithm that we are using is totally reliable to us. Clear?
Okay.
So various algorithm you can apply on this, such as SAPE, LIME, and many agnostic algorithm, you can apply it here. After that, there is something called as biasness and fairness check that you have to apply. So what is biasness and fairness? Let us understand. Suppose that the algorithm that you have built is biased toward a particular religion or a bias toward a particular community. So this will create a problem. Like a recent incident happened, whenever you ask ChatGPT about Narendra Modi, it will give some like hateful types of thing. But for other leader, it is showing good thing. But for Narendra Modi, it is showing some opposite thing. So there can be bias in this model. This is an example of ChatGPT, I think 6 months to 8 months back. Yeah. Okay. So you need to make sure your biasness and fairness in your model. Okay. There is a tool of IBM particularly for that, which is called as IBM Fairness. So you can use it out in order to perform the biasness and fairness checking. Any doubts in this?
In this, okay, this I clear now, Bruno. Yeah.
Once this thing is done, what we will be going to do? You will be going to create an API, like you will create some API using Django or Python programming language, or you can go with Fast API, another way of creating APIs. And
Test APIs.
And you will test the API using the Postman. Postman is basically a tool which is used for API testing and deployment part.
Yes, yes.
So it's very important to test it out. So you perform various types of system testing, and when you do unit testing, you run various types of checks, like several checks you will be run, like every time that you are getting the accurate result or not. So this thing, you have to done it. Once this thing is done, what we will be going to do, you will be going to just deploy it in your cloud application, like your Google, AWS, or Azure. So you can use it any one of them. Now there can be various deployment strategies that software engineer follow. Like we have A/B testing types of deployment. Then we have something called as pre-deployment and
Blue green A/B testing. Yeah.
Yeah. So A/B types of deployment is there. Canary testing is there. Right, releasing it to a set of user, then deploying it out. So there can be various testing strategies that software engineer use it out. Clear?
Mm-hmm.
Now, once this thing is done, now CI/CD starts. CI/CD means continuous integration and continuous deployment. Like when you're deploying the model, now you will make some changes in the model and again deploying it back again. So every time you are doing some addition of features or any integration will be there to the existing model, you are automatically deploying it. So for that part, we use something called as Docker. We can use it for we can use it for Kubernetes also, and then we can use it for GitHub Actions also. So there is various tools which we can use it out. Yeah.
Yes.
So anything which can be used for CI/CD CI/CD pipeline. Now, what happened in CI/CD? Let us try to understand it out. There is something called as model monitoring. So you have to, every single time you have to measure the performance of the model. And let us say your performance degraded over a period of a time. So what we will do, you will set some alerts. Like if my model performance is less than 50%, alert me through me an email. So these things can be done with the help of tools like Prometheus and Grafana. So everything will be measured from your performance monitoring to your even data quality monitoring. Everything we are monitoring it here. If there is anything goes wrong, there will be emails coming back to you, like warnings coming back to you, and you have to retrain your model again and again. After that, after retraining your model, you can update your model. Clear?
Yes, good.
Once this thing is done, you need to make sure that your model governance will be there. Like your model is following all the rules and regulation are there. Like it not should discriminate the politician or any other thing. Any community will be there. Any religion cannot be offended in there. So all the governance types of thing, like all the data that you are using in a particular way or not. So your model governance will be done. And this is your final step. After that, cybersecurity comes into the picture for providing the security for your machine learning models. So there is several separate field for that, which is called as adversarial machine learning. So here cyber guy comes into the picture and they will try to test your model, like try to do some attacks on your model. So make sure that your model cannot be get manipulated. Because if you change a single bits in the image also, the output will get damaged. So cyber guy comes picture here in adversarial attacks. Okay. So this is the whole pipeline of your machine learning algorithm. Every time there will be some performance degradations will be there, model retraining will be automatically happening. So you'll be setting some overall pipeline for this, it will be automatically happen.